Hi everyone. In this presentation, I'll be talking about our paper titled An Adapted Fusion Prompting Technique using ChatGPT to Advance Low-Resource Languages Understanding. In this work, we explore how we can use large language models like ChatGPT to improve performance on language understanding tasks, particularly for low-resource languages. By designing better prompts, we show that even in zero-shot and few-shot scenarios, ChatGPT can deliver impressive results across different languages. Let's jump in and explore the details. We live in a multilingual world where understanding diverse spoken languages is becoming more important. But here is the problem. The English language dominates most natural language processing applications and datasets, while labeled data for low resource languages is still scarce. Since labeling is time-consuming and expensive, a promising solution is to use cross-lingual transfer models that transfer knowledge from high-resource languages to low-resource ones. But these models often struggle with languages that are distant from English due to differences in syntax, morphology, word order, and script, which makes knowledge transfer less effective. This is where LLMs come in. They offer a powerful alternative, but the key to success lies in how we prompt them. The way we provide examples from no examples, zero-shot prompting, to carefully selected adaptive examples can make a huge difference. That's what we focus on in this paper. Um, Zero-shot prompting works by asking the model to perform tasks using its pre-existing knowledge, while few-shot prompting gives the model a small set of task-specific examples to guide its prediction. The success of few-shot prompting heavily depends on the quality and relevance of these examples, especially for domain-specific tasks. So not all examples are equally valuable, which is why we need a smarter approach. In our work, we refine the example selection process to make sure that the examples we provide are informative and relevant to the given domain, mainly for the two key tasks of language understanding, intent detection and slot pulling. So we propose a two-step approach. First, we generate machine-generated examples using an effective cross-lingual transfer model. Then we select a few of these examples that best support our tasks to guide the LLM effectively. To do this, we identify the domain of the input, like alarm or weather, using any model, even the LLM itself. Then we apply our adapted fusion technique to select the most informative example tailored to that domain. Just one important thing to note, we treat the cross-lingual transfer model as a black box, which gives us the flexibility to employ any model for this part. We rely on this transfer model to minimize the need for additional language-specific supervision, which makes our approach more adaptable. Let's dive a little deeper. In its basic form, zero-shot prompting involves feeding an utterance to the LLM and simply asking it to predict the corresponding intent or slots. But for adapted few-shot prompting, domain-specific example selection is important and essential. So to achieve this, we first generate domain-specific examples from our unlabeled dataset by following a sequence of steps. We label each utterance automatically, giving us a rapidly generated annotated dataset. Then we filter these examples by domain and select a few of them to guide the LLM. For selection, we use a greedy approach, sorting utterances by length to ensure diversity in slot representation and picking the most informative ones based on criteria I will discuss shortly. Uh, this process is mostly automated to reduce costs, but we also had a reviewer check the examples to ensure quality and minimize any noise that might be injected into the prompts. Uh, Now a question is raised that what makes an example truly informative? What makes a good example? When selecting examples, we focus on three key criteria to make sure they are both informative and relevant. Lengthy utterances provide more slots, giving the model a wider variety of patterns. But these slots must be meaningful. Utterances where most tokens are labeled as O or carry no meaningful information are not useful. We also aim to increase diversity by selecting examples that introduce different slot-oriented types one after another, which improves generalization. Here is an example in Spanish. The top example meets all the criteria, while the one below is too short and lacks meaningful tokens, making it less informative and useful. Now let's look at some of our results. We evaluated our approach using the Facebook multilingual dataset for Spanish and Thai. As you can see, our adapted technique consistently outperforms other prompting approaches, including random example selection. This shows the importance of using domain-specific examples to boost performance. Our method also outperforms the state-of-the-art models for intent detection, showing its effectiveness. For slot filling also, the results are strong for Thai and match the performance of existing models for Spanish. We observed a similar trend for Persian. The Persian dataset includes 26 intent classes, making it a bit more challenging for the LLM to predict all intents correctly. But despite this complexity, our approach is still performed remarkably well, showing consistent improvement in slot filling. To wrap up, our results show that our adapted few-shot prompting technique is robust across different languages and tasks. We stick to a cost-effective approach compared to fine-tuning, making prompting a practical choice for low-resource settings. But exploring the trade-off between fine-tuning and prompting is an interesting avenue for future research. Also, benchmarking against diverse LLMs and expanding evaluations to cover a wider range of languages could offer deeper insights into the scalability of our approach. If you have any questions or want to discuss this work further, please feel free to reach out via email. Thank you.